This lesson is all about specific latent heat. You can use this PowerPoint, go through it, pause it when you need to make notes or answer questions, or just watch it all the way through and use the PDF that goes with this lesson to make your notes. So let's have a think about this. First question, how does sweating cool you down, and link that to specific latent heat? First of all, let's just link it to particles and energy, and then when you come back after you've watched all of this PowerPoint, then you might be able to add more detail to it. So when you think about it, when you're sweating or when you've got water on you, if you come out of the swimming pool, the water will need to evaporate, so it'll need to change state from liquid to gas. And to do that, it's going to need energy. So where is the energy going to come from? Well, it will come from your body. So if the energy is being transferred from your body, the heat energy, you are going to feel cooler. So these are the objectives of what you need to know. Define latent heat, use the equation, and interpret heating and cooling curves. So this last bit we've met before and we'll come back to. This is just a refresh of your change of state, solid to liquid to gas. These words, freezing or solidifying, melting, condensing, boiling or evaporating, you need to know. Sublimating is a special change of state where it goes straight from solid to gas. So, what is specific latent heat? Well, here's your definition here. It's basically what we were talking about at the beginning. It's the energy needed to change the state of a substance, okay? So, you've got your definition here. It's the amount of energy needed to change 1 kilogram of the substance from one state to another without changing its temperature. Be careful you don't mix it up with specific heat capacity. A lot of people do. But this particular heat transfer, what we're talking about, is without changing the temperature. And the energy is either absorbed, taken in, or released, goes out, depending on the change of state. So each material will have its own specific latent heat for changing states. Now these are two definitions that you need to know. Changing between the solid and the liquid is latent heat of fusion. And between a liquid and a gas, latent heat of vaporization. Think vapor, gas. So just make sure you've got the right word with the right change of state. So fusion, if you think fusing, solid, and vaporization, a gas. Okay, so you need to know the definition, but of course you also need to know the equation. So here it is here. This is one of the equations you will be given in the exam, but make sure you know what everything stands for. So capital E, always for energy, and always energy measured in joules with a capital J. If you write it lowercase, you'll get it marked wrong. Mass, the standard unit of mass, always in kilograms. So if it's in grams, you need to change it to kilograms. And L is the latent heat of that material. And that's measured in joules per kilogram. So here's the triangle here. So here's a worked example. So the specific latent heat of vaporization for water is 2,200,000 260,000 joules per kilogram. How much energy is needed to completely boil 1.5 kilograms of water at 100 degrees Celsius? The equation doesn't have the temperature in. Well, that's just telling you that it's 100 degrees vaporization. The water is changing from liquid to gas. So as usual, write everything down in the equation, and so you can be clear about what you need to find out. And in this case, they haven't given you energy, so question mark, that's what we need to find out. Mass is 1.5 kilogram. Latent heat was given to you in the question. So all you need to do for this one is substitute everything in, and here is the solution. 1.5 times 2,260,000, and for that you'll get 3,390,000 joules. What, have a think about this, would be your answer in kilojoules? What would you have to do? We'll just have a look at these graphs again to remind you. You've met them previously. You've got a graph showing a change of state from solid to liquid to gas. So that is heating, and this one is cooling, going from a gas eventually down to a solid. So you have to be able to recognise these graphs and remember how they describe a change of state. Let's have a look at these graphs in more detail. Latent heat is the energy needed to change the state of the substance. So in the graph here, it's changing state, and here it's changing state. So basically, the latent heat is represented here and here by the flat parts of the graph. So here's a question for you to try. So the diagram below shows particles in liquid, and the liquid is evaporating. First question is, how can you tell that the liquid is evaporating from the diagram? Second question is, the temperature of the liquid in the container decreases as the liquid evaporates. Use kinetic theory to explain why. Well, your kinetic theory is just your particle theory, so you're going to use particles in your answer. So first of all, you can tell it's evaporating because the particles are shown leaving the liquid. You can use the word molecules or atoms for particles. Particles getting further apart is insufficient. That means you're not giving enough information. Your answer isn't related to the question. The question is all about the liquid evaporating, so the particles have to escape from the container. The second part, particles with the most energy leave the surface of the liquid, so it's like a puddle of water evaporating in the sun. So if the particles with the most energy have left, that means that the average energy of the remaining particles go down. If you've got less energy, then the remaining particles have got less energy, and the liquid temperature is lower. So don't talk about the particles being warm, warmer, cold. So you talk about the energy of the particles, but overall the temperature of the liquid decreases. Here's some questions for you to practice. You can either pause this video and practice them, or use the PDF that goes with this lesson to work through in your own time and at your own pace. There are solutions here for you as well to green pen your answers.